Okay, hello, welcome. I'm Matthew Brown, Director of the Center for Values in Medicine, Science, and Technology at UT Dallas, and it's my pleasure to welcome you all to our first online symposium. The Center for Values has been running an annual public lecture series since 2010 and an annual conference since 2011. Unfortunately, many of our events this year were canceled due to the pandemic, including what would have been our 10th annual conference. And so it's with great, I send my great thanks to my Associate Director, Magdalena Groman, who's helped us celebrate these 10 years of programming by jumping into an unanticipated role as a coordinator and producer of a variety of online events and content, including our new Brief Thoughts series of short videos, which you can find on our YouTube channel, and this symposium, which I suspect is not our last live event. Could I see the next slide, please? So our speakers today are Elyse Purcell, who comes to us from SUNY-Oneonta, Justin Biddle, who's coming to us from Georgia Tech, Dan Hicks, who's coming to us from UC Merced, University of California, Merced, and Mark Tschaepe, who's coming to us from Prairie View A&M University. So what we're going to do is each of them is going to give their talk, about 15 minutes. At any time, if you have a question that you want to ask, you can write it in the Q&A function on the right-hand side of your screen by clicking on the My Questions part of that function. We'll hold all these questions until all of the speakers have given their talks, at which point I will direct questions at the appropriate speaker. So we plan for the event to be about 2 hours long total. You can continue to participate through the My Questions feature throughout that discussion period. Next slide, please. Without further ado, I'd like to introduce Elyse Purcell from SUNY-Oneonta, who's going to talk to us on beneficence and potential harm, disability, and genetic enhancement.
Well, thank you, Matt, and thank you, Magda, for arranging this video conference, and thank you all for attending. The title of my talk is On Beneficence and Potential Harm, Disability, and Genetic Enhancement. Now, when it comes to using genetic enhancement technologies and genetic engineering technologies, there really isn't a controversy concerning using these technologies to eliminate a painful disease or disability that would result in a life not worth living. However, where there is controversy is whether or not we are obligated to use these technologies to prevent disabilities in general. Next. So to begin, I want to talk about some terms that are used in the debate. And when we talk about harm, what we mean in contemporary usage is making someone worse off than they otherwise would have been, or it's to put someone in an intrinsically bad state. Beneficence is sort of the opposite. It's promoting the best interest, especially health interest, for the individual. In the genetic enhancement debate, philosophers will often use functional enhancement versus human enhancement. They sort of change those terms up a bit. A functional enhancement is the enhancement of some capacity or trait, such as vision, memory, intelligence, or health. It's usually what we talk about with designer babies. Whereas human enhancement is an ideal. It refers to enhancement of a human being's life. Next. There are some problems, though, when we look at empirical studies on functional enhancements, and it's really the problem of trade-offs. So studies were done on memory acquisition and retention in mice and rats, and scientists in one study increased the production of NR2B subunits of the NMDA receptors. And there was a benefit. It was enhanced memory acquisition and retention, but there was a trade-off in this. There was a harm that came with the enhanced mice. It was increased sensitivity to certain forms of pain. So while it might be really nice that I get memory that works where I can do well on tests or remember my grocery list, if I stub my toe, it's going to hurt a lot more. So scientists did another study, and this is where they increased the signal transduction of protein adenylyl cyclase. And in here, they enhanced memory recognition, and that was the benefit. However, the harm that came was it was difficult to unlearn areas such as fear conditioning, and it ended up taking longer. So again, while it might be great that I can remember my colleagues' faces and have better memory recognition, if it's going to take me a lot longer to get over traumas and phobias, maybe this isn't the kind of enhancement that I want. Next. Now, sometimes philosophers say, well, what if we think of functional enhancements as all-purpose goods? And these run into some problems because, first off, when we think about a capacity that would be an all-purpose good, we have to figure out, do we mean just by having it, such as possessing it, or actually exercising that capacity? And this is the difference between doing versus having. And we know that well-being results not only from having the capacities, but also from exercising one's capacities. That way we actually experience the joy and the meaning in doing those activities. And this leads to another distinction that we want to draw when looking at functional enhancements as all-purpose goods. Do we value them intrinsically, meaning do we value the capacities in themselves, or do we value them instrumentally? Most of the time these capacities are instrumental. They're a means to, constitute our well-being. For example, if I have great health, then maybe I want to use that as a means so that I can win a marathon or play soccer with my friends. And finally, we run into the issue of, well, the more of these all-purpose goods you lack, what does that mean? The worse your life? And we know from studies in disability research and well-being research that they say otherwise. In fact, often, just because you don't experience a rich aesthetic moment, like looking at a painting, it doesn't mean that your overall well-being goes down in life. Next. So sometimes philosophers say, especially those that are transhumanists, they say, well, what about human enhancement as the ideal? They say our aim is actually enhancement that should be considered as a means to a desired end or consequence. This is the desired end of increasing well-being overall. And transhumanists are committed to a consequentialist framework. But what's also going on in the background with human enhancement as an ideal is a different account of harm, and it's a deprivation account of harm. And everyone is probably familiar with the classic deprivation account of harms, the Future Like Ours account, FLOA, by Don Marquis, that began in 1989. And Marquis said that killing is a harm. He's talking about abortion. He says, because it deprives one of all the experiences, the activities, the projects, and enjoyments that would have made up one's future. So if one is killed, then one is deprived of all the value of one's future. One is deprived of a future like ours. Oh, can everyone hear me? Okay. So again, one is deprived of a future like ours, and that's a problem. So the question at stake for germline genetic enhancement debates is whether we are obligated to provide our future children with a future better than ours. Stated differently, is there any harm done by not enhancing one's children? That is, only giving them a future like ours. Next. So the question becomes, are we morally obligated to enhance? And Walter Veit has argued that transhumanists say yes, that they are committed to the position that parents have a moral obligation to enhance their children. And he says, by accepting the principle of procreative beneficence and the consequentialist principle, the two acts with the same consequences are morally on par. He says this is the same kind of way that consequentialists view killing versus letting die. By looking just at the consequence, they're morally equal. And then he provides the transhumanists with a dilemma. He says, look, go ahead, you need to bite the bullet with regard to advocating for human enhancements, or you should give up the consequentialist position advocating for the principle of procreative beneficence. Next. So if Veit is correct with his argument, then two other challenges emerge for transhumanists. And the first challenge that I'd like to present to them is what I kind of call not just like the trolley problem. Now, the origin of the trolley problem can be traced back to two examples given by Philippa Foot in 1978. In the first example, a judge must choose between either framing and killing an innocent man or allowing 5 innocents to be killed in a riot. In the second example, a trolley driver is given the choice between either turning the trolley so that an innocent man attached to the track is killed or doing nothing, thus allowing the trolley to hit and kill 5 innocent people. Now, Foote argued that it was morally wrong for the judge to kill, but it was not morally wrong for the trolley driver to do so. Foote drew a distinction, that of doing harm in contrast to allowing harm. In the first case, the judge must choose between either doing harm, that is framing or killing the innocent man, or allowing harm, and that was allowing the 5 innocents to die. The trolley driver, by contrast, must choose between 2 cases of doing harm, killing 1 or killing 5 innocents. Now, the trolley problem that all of us really know today is the one that we get from 1986 with Judith Jarvis Thompson. She modified the trolley problem by changing the agent from the trolley driver to a bystander who had to make the decision. And this modification was important because now the bystander had to choose between doing harm, killing the 1 innocent, or allowing harm, allowing the 5 innocents to die. The doing-allowing distinction is relevant to the use of genetic technologies when we look at the principle of procreative beneficence. In essence, the moral obligation to genetically enhance one's future child assumes the parent must commit this act in order to do good. And if one does not use these genetic enhancements, then by doing nothing, that is an omission, one has allowed harm to occur. So the reason the principle of procreative beneficence within a consequentialist framework is not just like the trolley problem is because transhumanists have lobbied for the position that parents have an obligation to ensure positive outcomes rather than just equal opportunity. So stated differently, is there any other case where an agent has a moral obligation to ensure positive outcomes? This is a sui generis conception of harm, and it doesn't really generalize into our other notions. Now, a further question arises, and this again goes to a deprivation account, one of a better future. If the parents opt out, that is an omission, what is the deprivation? The child has not been deprived of a future like ours. The child has only been deprived of a future better than ours. Is it a kind of harm if we do not provide a future better than ours? Next. So the next challenge that I have is a clarification challenge. What is actually meant by the best possible life? Now, for words to actually be meaningful, their use must be defined in some sense. This ensures meaningfulness. And without some sense of how to answer this question, one runs the risk that enhancement, defined as the improvement of some set qualities X, turns out to be an empty set. So the burden of proof shifts to the transhumanist to show that their view is meaningful in some relevant sense. Now, the transhumanist might respond that the best life is realized by the addition of various human enhancement technologies. This is the fact that we can actually refer to various social scientific studies and theories of well-being, whether they are hedonistic or desire satisfaction or objective list. It doesn't really matter, any of these will do. But if that's so, they run into a dilemma. So on the one hand, transhumanists have opened up the possibility of a different conception of the good, for which the addition of genetic enhancement technologies might not be necessary. Or they are guilty of holding a particular conception or conceptions, a limited conceptions of the good, the achievement of which requires the use of genetic enhancement technologies. So we have to ask, which one will they choose? If they choose the former, the first one, then it's conceivable that one's life could go better living with disabilities than without them, and they don't need to use genetic enhancement technologies. If they choose the latter, then they are not in support of moral pluralism because they're only looking at a limited conception of a few possible goods at best. And this way they're sort of conflating moral reflection versus what we know in scientific and social scientific knowledge concerning living with a disability. Next. And so we have to ask, what is the source of this trouble? Well, feminist scholars and disability scholars have pointed out that transhumanists have assumed a maximalist view of well-being. And the maximalist view holds that that life is presumptively better with more valuable capacities. So the more, the merrier. And since people with disabilities have fewer valuable capacities, then it is presumed that this loss makes life go worse. But there is not necessarily a connection between having a disability and having a decrease in one's overall well-being. As Elizabeth Barnes has pointed out, just because there's a harm at the onset of a disability, that does not necessarily connect with making your life go worse overall. We have to delink the onset of that harm with disability as a negative difference maker. And part of this confusion might be because of the disability paradox. And it's what researchers have found is that a large part of able-bodied individuals do not recognize that people with disabilities can lead good lives. And this is usually due to a failure of imagination. And this is what we call in social science the focusing illusion, where individuals have a tendency to focus on that initial loss of, oh no, if I became a paraplegic, then I wouldn't be able to use my legs. And they don't actually see the whole picture, the fact that you can be just as happy overall in your life, so after an adjustment period. So the question that we have to ask the transhumanists then is, how can one know one has lived the best life as an outcome if one lacks the epistemic authority, especially from a disability perspective, to judge? Next. Thank you.
Okay, next up we have Justin Biddle from Georgia Tech. His talk is Predicting Recidivism, Value Judgments, Trade-offs, and Power Dynamics in Machine Learning.
Okay, thank you. First of all, I'd like to thank everyone at the center at Dallas for organizing this event. I know it's not easy to organize an event like this and get the technology working so that everyone has, so that it's working for everyone and so on. So thanks for organizing this. What I'd like to talk about today, next slide, please. Next slide, please. Is a project that I'm working on the role of value judgments in the design and development of artificial intelligence technologies, and in particular machine learning technologies, and particularly machine learning systems that are used to either replace or assist human decision making in ways that has significant impacts on human beings. And one of the reasons why I'm interested in this project is because of claims that I've run across in various different contexts to the effect that AI or ML-based systems might be able to either eliminate or at least reduce the role of value judgments in scientific and technological decision-making. And the idea behind this seems to be that, well, scientific and technological decision-making are significantly value-laden in part because they're done by human beings who are prone to value influences. But if we turn these decisions over to supposedly neutral algorithms, we could eliminate or at least reduce the role of value judgments. And what I want to argue is that that's not the case. We can't do that. Next slide, please. In particular, I want to argue that machine learning systems are value-laden in ways similar to human decision-making because the development and design of ML systems requires human decisions that involve trade-offs that reflect values. And so the important questions surrounding these systems are not whether they're value-laden, they are, and significantly so, but how they're value-laden, whose interests they serve, whose values they reflect, and how they might be designed and implemented to affect positive change. What I'll be talking about in this talk are some highlights from a paper that I have forthcoming, should be out any day now, in the Canadian Journal of Philosophy. And what I try to do in that paper is to discuss the role of value judgments in machine learning generally, and in the development of recidivism prediction tools in particular. Recidivism prediction tools have begun to be used extensively in various countries, including many states in the United States, and they've received a lot of attention in the legal community and also in computer science community, even before 2020 and the events of the last couple of months. But the events of the last couple of months and scrutiny of the mass incarceration system, I think, makes issues around recidivism prediction and the use of these tools even more significant. Next slide, please. By the way, just if you're not familiar with the term recidivism prediction, these are tools that are used to assess in a supposedly objective manner the risk of an individual for reoffending if they've already committed a crime. We know that the United States has certainly one of the highest incarceration rates in the world, the highest among those countries who actually give data about this sort of thing. And we also know that people of color, Black and brown people, are incarcerated at disproportionately high rates. There's been quite a bit of discussion about the use of, again, quote unquote, objective risk assessment tools to address some of the problems that we see in the mass incarceration system. Some groups, including the White House Office of Science and Technology Policy, have argued that the use of AI or ML-based systems could help to lower incarceration rates by reducing racial and ethnic bias. And one of the things that I want to do in this talk is to examine these systems by scrutinizing the role of value judgments at various places in their design and development to get a sense of whether or not that could be a good way to go. Next slide, please. Real quickly, the philosophical framework that I bring to this project is that of epistemic risk, which is a framework that I've been working on with Rebecca Kukla and some other folks. We define epistemic risk as the risk of error or epistemic failure at any point in a knowledge productive enterprise. And kind of one of the things that we want to do with this framework is just to emphasize that there are various ways in which a project can go wrong, epistemically speaking, and various points throughout a research project in which that can happen. Throughout the course of a project, researchers must make contingent decisions. This is a term I get from Matt Brown. Contingent decisions that could go in a variety of different ways that involve trade-offs that reflect values, and in particular value judgments about the relative costs of different types of error or failure. And different ways of managing these epistemic risks have disparate impacts on different groups because different errors impact different groups in different ways. Next slide, please. There are a variety of different types of epistemic risk throughout the course of machine learning development and design. I will focus on problem setting and framing, decisions around data, and a couple of different decisions around algorithm design. There are other areas that are important: building, testing, deployment or implementation, and monitoring. If I have time to say something about deployment, I will, but I fear that I might not. Next slide, please. Okay, so if one is thinking about developing an ML-based system for addressing problems in the criminal justice system or the penal system, the first thing that one has to do is to define the problem that one's trying to address, or to frame what one takes to be the relevant problem. And it's worth emphasizing that there are a variety of different ways in which one might frame the relevant problem. which and how one frames the problem will have impacts, different impacts on different groups. And it's not at all obvious that the right way to frame the problem is in terms of assessing the risk of would-be offenders. Technological systems are instruments of power that are used by some groups on others. Recidivism prediction tools are used by states on disproportionately disadvantaged groups. And it's not at all obvious that that's the right way to frame the problem. At the end of the talk, I'm going to talk about or just bring up one potential alternative way of framing the problem that would have significantly different impacts on different groups. But assuming that one has made the decision to frame the problem such that recidivism prediction algorithms are the way to go, one then needs to make a contingent decision about how to operationalize the concept of recidivism. There are many different recidivism prediction tools in use. Different countries use different tools. In the United States, different states use different tools. One of the ones that I'll reference a couple of times later in this talk is a proprietary tool called Compass, which has received quite a bit of attention. But there are many different ways in which one might operationalize the concept of recidivism, again, with very different impacts on different groups. Next slide, please. So what do we mean by recidivism? Well, in order to operationalize the concept of recidivism, we need to define what it means to offend and what it means to re-offend. And again, different designers make different decisions about how to operationalize these concepts. What do we mean by offending? Well, one might mean arrest and conviction, arrest and being charged with a crime, or simply being arrested. What do we mean by re-offending? Re-arrest and conviction, re-arrest and formal charges, re-arrest whether or not one is charged, or simply a violation of probation. Again, different tools operationalize this concept in different ways, but many of them define recidivism in what might think of as very loose terms, in terms of arrest whether or not one is charged, and re-arrest whether or not one is charged. Many designers operationalize the concept in this way because it's easier, relatively speaking, to get a lot of data. If one, say, makes a different decision and defines recidivism in terms of arrest and conviction, one has to wait for legal processes to go forward, and it's going to take longer to get data that can be used to train a system. If one defines it simply in terms of arrest, whether or not one is charged, one can obtain larger amounts of data more easily and conveniently. So one is really kind of prioritizing data quantity and convenience here, but that arguably comes at the expense of equity, because by defining recidivism in terms of arrest whether or not one is charged, one will have that will have disproportionate impacts on groups that are heavily policed. It's worth noting that defining recidivism in this way can result in people counting as recidivist without ever actually committing a crime, simply being arrested on more than one occasion. Next slide, please. The next area in which there is significant epistemic risk that involves trade-offs that reflect values is in decisions about data. Machine learning systems work on the basis of data. They input large amounts of data that train algorithms. Because there is no sort of objectively correct answer to the question of what kind of data sets we should use, right? There are different data sets one could use to train a system. There are different ways of cleaning data, and so on and so forth. These different decisions will have significant effects on the performance of these systems. Next slide, please. One area in which we've seen this very predominantly and very prominently is in facial recognition technologies. There's been a lot of discussion about the fact that these technologies work fairly well when it comes to white faces and work rather poorly when it comes to black and brown faces, in particular the faces of black women, and that results from decisions about what data to input to train these systems. Next slide, please. In the case of recidivism prediction tools, there's a lot of discussion about what data should be used to train these systems. Some data that are used by various systems include criminal history, age at first arrest, gender, socioeconomic status. But again, these are contingent decisions that have disparate impacts on different groups. And these decisions, I would argue, involve judgments about how to trade off accuracy and ethical considerations such as equity. So think about socioeconomic status. It does seem to be the case that socioeconomic status is correlated with recidivism. To put it bluntly, you're more likely to recidivate if you're poor. And so for reasons of accuracy, you might want to input as data, data about socioeconomic status. However, it seems that that has pretty clear implications for equity and the ideal of equal consideration under the law. All else being equal, a poor person will, if this data is input, have a higher risk status than a wealthier person if that poor person then has a longer incarceration sentence. As a result of that, that seems to be a clear violation of the ideal of equality under the law. Next slide, please. So this next area that I'd like to talk about where there are epistemic risks that involve trade-offs that reflect values is in algorithm design. There's been a lot of discussion about the choice of different algorithmic techniques and trade-offs between accuracy and explainability. In the interest of time, I'm not going to go into that here, but I'll just note that it is an important area of discussion. Next slide, please. One type of decision in this area of algorithmic design that I would like to talk about is the issue of algorithmic fairness and what it means for an algorithm to be fair. This is a discussion that was spurred in part by an article in ProPublica called Machine Bias that alleged that a particular type of software, Compass, that I referred to earlier, which is a proprietary software that is used in a number of states in the United States, is racially biased, in particular racially biased against Blacks. Next slide, please. ProPublica obtained and analyzed risk assessment scores for over 7,000 people arrested in 2013 and 2014 in Broward County, Florida. Florida is one of the states where Compass is used. And what the ProPublica authors found was that while Compass does correctly predict recidivism 61% of the time for both Black and white populations, the likelihood of different types of error differ significantly based on race. And in particular, those who were labeled higher risk and didn't reoffend, 23.5% of white people versus 44.9% of Black people. Those labeled lower risk and did reoffend, 47.7% white people versus 28% of Black population. So the algorithm systematically sort of overestimates the risk of Black people and underestimates the risk of white people. This article led to a really serious discussion in computer science communities and others about these notions of algorithmic fairness. Next slide, please. And what they found was that at least under certain empirical conditions, it's mathematically impossible to satisfy all of the conceptions of fairness that we might want to satisfy. So Verma and Rubin identified 20 different distinct conceptions of fairness. Two of them in particular that are particularly important here are predictive parity and equalized odds. Roughly, predictive predictive parity is the probability that one recidivates if one is given a high risk of recidivism, that those probabilities are the same for different groups. However, equalized odds is a different conception of parity that concerns different error rates. I'm going to run over this quickly because I'm running out of time. But what this result showed was that under certain empirical conditions, in particular empirical conditions in which there are different base rates of recidivism, that it's mathematically impossible to satisfy both of these conceptions of fairness. So one has to make a trade-off between them. Next slide, please. Am I out of time? Okay, I've got a couple minutes. Okay, good. The final area of algorithm design that I want to mention is just output selection. Again, there are many different contingent decisions that one could make about what an algorithm should output. What COMPAS does is it generates a probability of rearrest relative to a population. And then on the basis of that probability, it assigns a score of 1 to 10 and then places people into one of three categories: low risk, medium risk, or high risk. And note that there are significantly different implications of outputting simply a probability of rearrest relative to a population versus putting someone in a category of either high risk, medium risk, or low risk. In making the decision to do what COMPAS did, which was to put one into one of those three categories, one has to make sort of inductive risk judgments about what counts as high risk versus medium risk, say. But one is also making judgments about who is best equipped to make inferences from the statement of a probability of rearrest relative to a population versus a risk, a particular risk category. Next slide, please. This is my last slide. Sorry, that's not my last slide. Go to my last slide, please. So in the paper, I provide 3 different recommendations for the use of these algorithms, given the types of value that are input into that are reflected in these algorithms and the impacts that these have on particular populations. But the one that I think is most apt is simply that courts should prohibit the use of recidivism prediction algorithms that can be shown to disadvantage groups that are already unjustly disadvantaged. And we can actually show that that is indeed the case with these algorithms. Again, any algorithm that satisfies the predictive parity criterion of fairness will fail the equalized odds criteria and will, in current empirical conditions, overestimate the risk of Black populations in comparison to white populations. And until that problem can be remedied, say by remedying the inequality of base rates of recidivism, these algorithms should simply not be used. Now, none of this is to say that ML systems in general shouldn't be used, as there might be alternative ML systems that might be preferable from the perspective of equity and power dynamics. So just consider, for example, the possibility of using ML-based systems not to assign risk of recidivism to would-be offenders or to supposed offenders, but would examine, say, judicial decision-making and try to evaluate potential biases in judges decision-making. That would be a type of ML system that would have very different implications for power dynamics and implications for, in particular, disadvantaged populations. Next slide, please. Thank you very much.
Okay, thank you, Justin. Next up, we have Dan Hicks from University of California, Merced. Their talk is about when virtues are vices, anti-science epistemic values, and environmental politics.
Okay. Is my audio okay? Great. So first of all, it says my mic is muted. Okay, you can hear me. Just a warning. Okay. Yeah, so thanks to Matt, Magda, and the other folks at the center for inviting me and organizing this session today. And thanks also to the other UT Dallas folks, especially Amanda, for doing technical support for the Microsoft Teams system. We've had some challenges, but it seems like everything is working really smoothly now. If you could go to my next slide, which should be my title slide. Yeah. So the title of my talk today is When Virtues Are Vices, Anti-Science Epistemic Values in Environmental Politics. Next slide. Okay. So what I'm going to be talking about today is a charge made in the context of contemporary environmental politics, especially in the US, but also to some extent in Canada, that certain approaches to making environmental policy are anti-science. I'm going to be developing sort of a paradox about this label. While I'm sympathetic to the way that it's used, it sometimes gets applied to certain policies or arguments for policies that appeal to pretty widely shared epistemic values. And so it's puzzling to think that something that appeals to epistemic values that a lot of scientists share could be, in some sense, anti-science. What I'm going to argue is that we can make sense of this anti-science label if we think in a certain way about the aims of science. So in part 2 of my talk, I'm going to be introducing the conceptual machinery to think about the aims of science in a broad enough way to accommodate this anti-science label. This is going to lead to apparent conflicts between epistemic and pragmatic values in the kinds of cases that I'm interested in here. And so I'm going to draw on some ideas from virtue ethics and the Deweyan pragmatist tradition to think through how we resolve those conflicts in a way that can maintain this anti-science charge. Next slide. Okay, so first I'm going to start with these motivating cases of the anti-science label in environmental politics. Next slide. Okay. If you've paid basically any attention to environmental politics and policy in the United States over the last few years, you're probably very familiar with the idea that the Trump administration is anti-science in the kinds of policies that it adopts and advocates for. So what we have here on this slide are a few headlines. One from a news story, another from an opinion piece published by 2 Obama-era EPA officials, Gina McCarthy and Jana McCabe, and then a kind of blog post from the president of the Union of Concerned Scientists. And they're all in various ways claiming that Trump's EPA is attacking science or working against science. Next slide. Now, I was particularly motivated to work on this project by a rule that the US EPA proposed a couple of years ago titled Strengthening Transparency in Regulatory Decision Making. This rule, if adopted, and there's some anticipation that it will be adopted sometime this summer, if adopted, under this rule, EPA will ensure that the data and models underlying the science that they use to make regulations are publicly available in a manner sufficient for validation and analysis. And with a few exceptions, this is expected to be a pretty broad and abrupt open science requirement for fields of science that don't yet have a really strong culture of open science. So fields like toxicology, certain areas of epidemiology, for example. This rule explicitly appeals to values including, quote, independence, objectivity, transparency, clarity, and reproducibility. And it explicitly references the replication crisis, which is a crisis that's been unfolding in primarily laboratory sciences, especially social psychology and the laboratory parts of biomedical research. Basically, this crisis, if you're not familiar, is this phenomenon that the laboratory studies, especially some high profile, very influential studies, are being replicated with a much lower rate than one would expect. And a common response to this is to call for open science, the publication of data and analysis scripts and pre-registration in order to mitigate this replication crisis in those other fields. And strengthening transparency, the justification for it explicitly appeals to these kinds of concerns, these appeals to epistemic values. However, at the same time, it's expected to be used to dismiss large bodies of really important work in environmental epidemiology and public health research on topics such as air pollution and pesticides. I have some examples there. And so the anti-science label has been applied to this proposed rule. Next slide. Okay, so this leads to sort of the paradox that got me interested here. Many philosophers of science have written on epistemic values, especially over the last decade. I think a really common definition comes from the work of Dan Steele. We can understand epistemic values as characteristics of scientists, their activities, and their products that promote truth or the pursuit of truth. And so we get this paradox. On the one hand, the critics, who I'm sympathetic to, want to argue that strengthening transparency and what I've called its ilk, so similar policies based on similar arguments, these critics want to argue that these things are anti-science, but two, they appeal to widely shared epistemic values among both practicing scientists and philosophers of science. And three, it's pretty plausible to say that no argument that appeals to widely shared epistemic values is anti-science. And of course, we can't have all three of these claims be true at the same time. So as I've indicated, I'm really sympathetic to the charge being made in the first claim here. And what I'm going to argue in this talk is that we can maintain this charge. We can say that rules like strengthening transparency and its supporting arguments are indeed anti-science if we adopt what I call the broad view of the aims of science. Next slide. So to develop this idea, I'm going to draw out some ideas from my specific version of what's called the aims approach to thinking about values in science. Next slide. So in my work, I've developed a general conception of science as a social practice, where by this I mean that science is a complex, collaborative, goal-oriented, socially organized activity. And today I'm looking specifically at the idea that science is a goal-oriented activity, or it's an activity that has aims that give a certain normative structure to science as a social practice. Next slide. So the diagram on this slide sort of illustrates the way that the aims of a practice such as science give it a kind of normative structure to how people doing that practice, namely scientists, should behave. So on the left-hand side, we have the aim of truth, which not all philosophers of science, but a lot of philosophers of science would agree that truth is among, at least, the epistemic aims of science. And on the right-hand side, we have some familiar epistemic values, things that promote that aim of truth. We have the kind of transparency given by open science, we have empirical adequacy, we have rigor, we have a skeptical attitude towards claims. And I've labeled these things virtues. So on my conception of a social practice, virtues are the characteristics of practitioners and their activities that promote the aims of the practice. So all these epistemic values promote the aim of truth. And so on the picture we have so far, we can label these things virtues, scientific virtues. Next slide. And this picture that we have so far is a really nice representation of what I call the narrow view of science, which is kind of a traditional view that I think a lot of philosophers of science and practicing scientists kind of assume implicitly. And the aim of my talk is to sort of problematize this. According to what I call the narrow view, truth is the only aim of science. That's the only thing on the left-hand side. And so this means that automatically anything we put on the right-hand side, an epistemic value that promotes the aim of truth, that will count as a scientific virtue. Next slide. What I call the broad view complicates things by adding additional aims to the left-hand side. Namely, on the broad view, science, at least the kinds of fields that I'm interested in here, like environmental epidemiology and toxicology, they have both epistemic and pragmatic aims. They want to produce knowledge, but they want to produce knowledge that lets us take certain kinds of action in the world. So here, to the diagram from before, I've added an additional pragmatic aim, protecting human health. And I've identified some things that we can call pragmatic values because they promote that aim. A precautionary attitude that's willing to accept claims with modest evidence, policy relevance, science that can address the needs of policymakers who are trying to protect human health, and timeliness, research that can be done relatively quickly so that it can inform rapid action to protect human health. And I've labeled the epistemic values from before as epistemic virtues with a question mark. And I've labeled these new pragmatic values as pragmatic virtues with a question mark. Because now it's not clear whether the things on the right-hand side, while they still promote their respective epistemic and pragmatic aims, they seem to be in tension with each other. And so it's not clear on the broad view whether we want to call these virtues. Next slide. So this slide illustrates conflicts, or at least apparent conflicts, between the epistemic and the pragmatic side of things. Because my time is short, I'm really going to focus on just one pair here, which is the apparent conflict between the kind of transparency that's promoted by open science and timeliness. Sabina Leonelli and several of her collaborators in a significant body of work have really argued that open science is really time and resource intensive. It requires a great deal of infrastructure. It requires a lot of know-how for researchers to do open science really well. It also requires researchers to collaborate with specialists in a lot of different areas. So you need software engineers, you need people who are experts in data maintenance. You need people who can think over the long term about how to maintain software so that it can be run on later operating systems, on later hardware. And so all this means that if you don't have that infrastructure, the social, the computer science infrastructure, the know-how necessary to do open science really well, it can be really, really time consuming. And so there's an apparent conflict here between the kind of epistemic benefits that open science can get and the fact that if you don't have all this background in place, it can really slow down research really dramatically. So we have a conflict, an apparent conflict between transparency and timeliness. Next slide. Okay, now we have these apparent epistemic and pragmatic conflicts, and I think we can resolve them if we draw on some ideas from virtue ethics, the Aristotelian virtue ethics tradition, and Deweyan pragmatism, although I've really suppressed those references here for the sake of time. Next slide. Okay, there are two different ways that we can think about what open science means. First, we can think of open science as just referring to sort of a one-time action by an individualized researcher as just releasing your data, making your data publicly available. If we think of open science in this way, open science in this sense, releasing your data, might help avoid some false conclusions due to things like coding errors. And in this way, it can promote reproducibility, a computational notion, do you get the same output when you run the same code on the same data? Next slide. But this way of thinking about open science won't address concerns about replicability. Do we see the same results on different samples when we collect new data? And it won't promote public understanding. So this first point is something that I actually talked about in a public comment I submitted on strengthening transparency earlier this year. And Kevin Elliott and David Resnick have a really nice commentary where they talk about open science and whether or not it can promote the public understanding of the science involved. This release your data conception of open science also ignores all of the infrastructure that I was talking about in the previous slide, identified by Sabina Leonelli, and so as a consequence it can lead to delaying research, both research and protective regulation. So it has both epistemic and pragmatic problems. Next slide. On the other hand, we can think of open science in terms of this extensive, ongoing, community-level project to develop the culture and infrastructure that it really requires. This can include explicitly developing infrastructure and know-how, including things like funding infrastructure projects, running workshops for scientists so that they learn how to use these methods. It can include shared standards for data publication, such as the FAIR data publication standards. And again, in line with Kevin Elliott and David Resnick's wonderful commentary, it can also lead to thinking of open science as a form of science communication. From this perspective of open science, the kind of hasty blanket requirements that we get with strengthening transparency are really counterproductive. They won't actually help to develop this culture and infrastructure for open science. Next slide. So what we did in the last slide was an example of what in the manuscript for this talk I called the reconceptualization of the epistemic value of transparency as promoted by open science. So when we were confronted with an apparent conflict between epistemic and pragmatic values, between transparency and timeliness, we can reconceptualize the epistemic value to remove the conflict. Now this involves exercising judgment in the Aristotelian virtue ethic sense of phronesis, and it also involves the Dewey and pragmatist notion of moral imagination, which Matt Brown, our organizer today, has written about a lot in a really wonderful book that is due out anytime now. This process of reconceptualization often results in a broader view of the epistemic value. And on this broader view, the original epistemic value, that original narrow sense of open science is just release your data, was actually vicious. It frustrated the aims of science, both epistemic and pragmatic. It was not a virtue. And so it's appropriate, because the original epistemic value was vicious in this way, I suggest that it's appropriate to call the original epistemic value anti-science, which gives us the charge that I was really interested in at the beginning. Next slide. And that's my talk. Thank you very much.
Okay, thank you, Dan. Our last talk today is by Mark Tschaepe from Prairie View A&M University. And he's going to be talking to us about human GAN coupling, a cyborg perspective for distributed morality.
All right, thank you. Oh, thanks, Matt. Next slide, please. So before I begin, I just want to thank Magda and Matt and the organizers of the symposium. I would much rather be in person causing trouble at UTD than this medium, but I still enjoy it. Thank you, Amanda, who, can you not see my video feed? Okay, sorry. But you can see the slides, right? Okay. Yeah, I don't know what's going on with my video feed. It's on this side. You got it? Okay, awesome. So we're good. All right, so thanks to Amanda, who's kind of like a television producer behind the scenes. She's like pointing at stuff and putting her thumbs up, and it's great. But anyway, I just want to thank everybody. And I also want to thank one of my best friends, Phil Bristow, who I believe is watching and who actually is the one who got me into GANs, to generative adversarial networks, and got me interested in ethical issues about them. Next slide, please. So generative adversarial networks, this is a really brief sketch. But just to give you a general idea of what they are, they're within neural nets, and they consist of two related models. So you have a generative model, or a generator, G, and a discriminator, or D. And basically, if you look at the diagram here, you have real images that are plugged into the discriminative model or into D, and G, out of random noise, creates fake images or inauthentic images. And the discriminator has to discriminate between what is a real or authentic image and what is a fake image. And so if you look at the image, you have actual handwritten numbers that are being plugged in. Those are real image. And then you have fake numbers or inauthentic written numbers that the G has produced, and the discriminator needs to label them as either real or fake. So this is a very stripped down, very basic version of a GAN. Next slide, please. So the analogy that's often used to understand how generative adversarial networks function is counterfeiting. So you have, on one hand, you have G, which is like the counterfeiter. So the counterfeiter creates fake money. And on the other hand, you have a detective who has to detect whether or not money is fake or if money is real. And what's interesting about this relationship in terms of a GAN is that it learns over time. So the generator, through kind of trial and error and through the feedback from the discriminator, learns how to create inauthentic artifacts that can pass or are more able to pass as authentic. And the discriminator, in the same regard, learns how to discriminate better and to locate or to discern whether or not an artifact is authentic or inauthentic. Next slide, please. So we see this a lot with regard to images and the reconstruction of images. So this is an example looking at a generative adversarial network that reconstructs faces from fMRI patterns using deep generative neural networks. So this actually relates back to Justin's talk with regard to machine learning and then the subset of deep learning within it. Next slide, please. So this has a number of uses, and in fact, this is a very limited list. To be honest with you, there are tens, if not almost hundreds of papers coming out on GANs every day, it seems like, and new functions for them that are constantly being discovered. So some of the more common or the more commonly known uses are deepfake audio, video, and text. So deepfake videos are, for instance, there was the video of Obama seemingly giving a speech which he never gave, but it synced perfectly. A lot of the fake political videos that are coming out now are due to GANs creating them. Also, gameplay, probably the most famous instance was when AlphaGo, which was created by Google, which played the game Go, beat the human Go champion, who then subsequently retired and said that basically everything is done, that once a machine beat a human at Go, that was it. There was no point in playing anymore. Also, medical imagery for data sets and diagnostic training. So especially with maladies that are very rare, there's very little that people can train on. So GANs actually produce images of inauthentic images of diseases or maladies that people can train with that pass for real. Image reconstruction and augmentation in autonomous vehicle control, GANs are absolutely necessary. Predictive marketing and selling. So the ads that you see popping up in your email or online oftentimes are tied to GANs. And there are a number of other uses for GANs. And as I mentioned, it seems as though there are new uses every day. Next slide, please. So what's the problem with GANs, or what's one of the problems? The problem that I'm going to talk about is when GANs have what I call troublesome creations, classifications, predictions, or recommendations. And in fact, this relates to the issue of predicting recidivism that Justin was speaking about. So the Compass case is a case that involves generative adversarial networks. So some examples include that, but also what are known as pernicious feedback loops. So misrepresentations in data lead to vicious cycles that perpetuate discrimination. That's more general, obviously, than the case of recidivism. In 2018, it was found that a GAN that Amazon was using, or an algorithm that Amazon was using, was actually imposing gender bias in hiring practices using their recruitment system. Also, and Justin mentioned this, racial and gender bias in facial recognition, bias regarding income prediction, again, recidivism, and as well as criminal sentencing. So GANs are actually used oftentimes by judges to sentence people who are found guilty. Misclassifications of people as non-human animals in terms of image analysis, or as blinking because of their eye shape. I believe it was in 2017, there was the case of a GAN being used on Facebook, which incorrectly translated a man holding a non-violent Arabic phrase into a violent Arabic phrase, as well as things like recommendations linking apps for locating sex offenders with dating apps. This occurred on Grindr. Next slide, please. And I realize this slide is chock full of stuff. This is just to give a smattering of the types of bias that we see related to machine learning and within machine learning to GANs. So things like popularity bias, where greater exposure of what's labeled popular results often into or is often manipulated by fake reviews as well as social bots. We see things like linking bias. So when a network, when the GAN actually attributes attributes to a person just because of who they're connected to, but actually misrepresents the actual user. Presentation bias, so because of how or what's presented, the user and the GAN feedback is skewed. A good example of this is in news echo chambers. So the more that you click on a certain type of news story, the more of that type of news story you'll see, and the more recommendations will be generated that assume that you're a specific type of person and that you will only be interested in a certain kind of content, and therefore you'll only be delivered a certain type of content. Next slide, please. So one of the problems is that GAN ethics, if there is such a thing, and I've never seen much that explicitly talks about GAN ethics. There's quite a bit now coming out about machine learning ethics, but specifically to generative adversarial networks, there's very little that's been written, at least so far, although again, there's stuff coming out on GANs daily. But it often equates these troublesome results with regard to the transparency of algorithmic code. And so there's this guiding assumption that somehow what the generative adversarial network is doing, or how it's learning and what it's producing in terms of outputs, is somehow separated from human users. And so responsibility for ethically problematic results is placed on the opacity of algorithms. And this becomes what's known as the black box problem of explanation with regard to algorithms. And algorithms can be opaque for basically two general reasons. One has to do with the fact that the algorithm is a proprietary object, and therefore the company that owns it is protecting it. But also it gets to a level of complexity that we simply can't understand the patterns that are being detected and being produced and being generated by the GAN. If generative adversarial networks are separated from us, resulting in some magical process that we can't alter or understand, so if we simply say they're separated from us, we can't do anything about it, this leaves us with little to try to solve or address problematic outputs that are related to GANs. Next slide, please. And so what I want to do is I actually want to go back to an essay by John Dewey, where he criticizes the reflex arc concept in psychology. At the end of the 19th century, there's this kind of shift away from a sort of spirit-body dualism or mind-body dualism, a kind of traditional Cartesianism within psychology, and it was replaced with this notion of stimulus and response, as if they were two separate things. And what Dewey argued was that stimulus and response are actually coupled within an activity, and they were in a circuit of activity. They were only artificially separated once we started analyzing it. And he went on to argue that this was true of an agent and their environment, the brain and the body, and input and output, that all of these were coupled in systems of activity. And I think similarly, we can recognize that the problematic separation of humans and GANs is an artificial separation, that the processes are actually one in which they exist within a circuit of activity. In other words, they're coupled. And so the way I refer to this, at least in writing, is as C/FE, which is from Isaac Asimov's Robot series, where he's talking about carbon-based and iron-based interaction between humans and robots. And I think that this is very similar, that we have this slash between C and FE to indicate that there are two different types of things at work, but that they are interacting, and that their interaction is necessary for specific types of actions or specific types of processes or specific types of outputs. Next slide, please. So following Dewey's criticisms of false dualism, so following his advocacy for coupling, I think that Donna Haraway's cyborg concept actually furthers the blurred distinction between humans and GANs. And I think that this is useful. Not only are humans and GANs coupled, not only are they C/FE, but also through the miniaturizing and translation of material reality into data, this makes things that were once overt less visible, less tangible, and increasingly uncontrollable. And oftentimes we see this if we go back to the output of GANs in things like bias or like predictions that have sexist and racist sentiments within them. Human activity is part of the procedural circuit that includes opaque algorithms. So it's not as if the algorithms are separated from our activity. This is actually a coupled activity. Human activity and GAN activity exist within a circuit, so to speak. So Haraway and Dewey steer us away from ethically problematic results that involve GANs as being solely due to opaque processes that are fundamentally separate from our own decision making. Next slide, please. And so what this points to is a notion of distributed morality. Organizations, systems, and machine learning are all recognized as part of moral agency through acknowledging this coupling, the fact that there is this kind of cyborg coupling. So ethically problematic actions that are related to GANs, if we actually stand back and kind of look at a larger picture, only exist because of cyborg systems, because of the coupling of human and GAN systems. If we impose a dualism on humans and GANs that separates them, then there's no resultant ethically problematic action. To put it another way, when we have humans separated from GANs, there are some results that are not going to occur. There are some processes that are not going to occur. So moral action is distributed across cyborg circuits, if you will. And as an object of ethical analysis, Mike Anani calls this networked information algorithms, which I think is a convenient term, as an object of ethical analysis. Next slide, please. So this is just a graphic indicating that if we just take human actions alone, there are some actions that are going to result in morally negligible or ethically unproblematic results. We're not going to have certain results that we would otherwise have with GANs. And if we were to somehow just look at GANs alone, as if we could separate them from everything else, and this often happens with regard to algorithm analysis, and especially with regard to black box explanations, also the actions result in morally negligible or ethically unproblematic results. It's only when we couple the processes together that we actually have morally substantial or ethically problematic results that occur. And so in this regard, it becomes useful to view humans and GANs as being coupled in a circuit of activity. Next slide, please. So just very briefly, I want to mention some next steps. So understanding cyborgs as the sorts of ethically problematic actions related to GANs provides a way to address issues such as bias. And there are some methods that we can use to help do that. One is value-sensitive design. And this is a general tool that takes values into account when analyzing the design process. This is usually not on the output end, but on the designing end. So this is one way to interrogate underlying biases. One of the problems that some people have pointed out with VSD is that it can often take this kind of Archimedean point of ethical inquiry as if it's outside, if it's decontextualized, which is problematic. But I think if we marry VSD with a feminist approach to human-computer interaction, this actually acknowledges the importance of cyborg coupling, and it may be applied to issues specifically related to GANs. So this supplies a standpoint approach, which is especially useful with regard to different types or instances of injustice related to cyborg processes. So it uses principles such as embodiment, ecology to understand issues of bias without simply acting as though we have this kind of universal standard by which we can judge what's going on with human GAN coupling, procedures, and outputs. Next slide, please. Thank you very much.
Okay, thank you, Mark. Thanks everyone for these talks. We have several questions in the queue, but please feel free, everyone, at any time to type your question into the Q&A function, and I will hand them off to the speakers. So, first question is for Elyse. It comes from Deepanwita Dasgupta. She asks about the responsibility of parents, the putative responsibility of parents to enhance their children. Depending on the state of technology, these number of enhancements might be endless. How many of them should parents adopt?
Yes, can everyone hear me? Okay, great. Thank you, Deepanwita, and thank you, Matt, and thank you, Amanda, for coordinating all of this. It's been wonderful. That's exactly the question, is that in theory, yes, we could have infinite numbers of technologies that are developed. And so part of the concern in the debate is whether or not we should actually limit access or the use or the future development of some of these technologies. With regard to genetic enhancements. And this is sort of where we run into an issue of a problem of paternalism, because should we ever limit the access that parents might have, or single reproducers, like what should we do? Should we have a limit? Should we have a balance? Also, another concern is the capitalistic structure and actual exchange, where it could be the case that in our system, access to these technologies goes to those with the largest bank accounts. And then that kind of could create problems of fairness within society. So should we have subsidies? What should we do? So that's actually sort of the center of the debate, and there's a lot of fear surrounding the possibility of, how do we actually make judgments about parents' adoption of these technologies, because this is the fear of designer babies and also our past history with eugenics, which was extraordinarily biased. So against so many different people.
Okay, thanks. Great. Our next question is for Justin Biddle. The question is from Janet Stimwadell. She asks, wouldn't a smarter algorithm calculate the probability of rearrest from features of policing rather than from properties of the individuals and communities being policed?
I'm pulling up the question here so I can, where is the question? Yeah, so it would. I think that the issue is that doesn't really get at what these algorithms are supposed to do. So ideally, what designers want from these algorithms is they want algorithms that objectively assess the risk of recidivism in terms of committing an actual crime and then being punished and then committing another actual crime. That's what ideally designers want these algorithms to do. The issue is that many of them use arrest as a kind of proxy for committing an actual crime, and they assume that that's a relatively accurate proxy. And what we know is that that isn't, right? That might be an accurate proxy for some groups, but for other groups, in particular, black and brown populations that are subject to really extensive policing, that's not an accurate proxy. And so, yeah, you could create an algorithm that more adequately assesses probability of rearrest from features of policing, but that's not ideally what designers want these algorithms to do.
Okay, our next question is also from Janet for Dan, and she references the practitioners of open science who practice open notebook science, who actually argue that their approach would be good for timeliness because it enables real-time collaboration, organized skepticism, and such.
Mm-hmm.
In a world where the scientific community, which commits to putting necessary infrastructure in place, is there any reason to think transparency wouldn't be a virtue?
Yeah, so if you do have the infrastructure and the culture that is required, yeah, something like open notebook science can be beneficial in terms of timeliness, in terms of getting like rapid feedback, ongoing feedback on sort of laboratory science as it's being done. I think, so for a couple of years, I was a postdoc in a data science center at UC Davis, where I would work regularly tutoring graduate students across UC Davis in using the software programming language R. And in my experience, those graduate students, even working in computationally intensive fields like computational biology, are still a ways away from really having like the skills to do open notebooks well. I mean, certainly some individuals do, but like at the level of the entire discipline, though that know-how, that culture is still being developed. And whereas fields like epidemiology, at least as I understand the state of the state of epidemiology or toxicology today, they still have a long ways to go in terms of developing that culture and infrastructure. Yeah, so in terms of policy, if this EPA policy had been written to develop that infrastructure to provide training, especially for graduate students and new PIs, for example, if that had been the way the proposal was written, I would probably be much more supportive of it, or at least I wouldn't see this tension between transparency and timeliness. But with the state of the fields as they actually are right now, and the way the policy is actually written, we get exactly the kind of conflict that I was bringing out in the talk.
Okay, thanks, Dan. Next question is a question for Elyse. It's a question about the definition of transhumanism. Does transhumanism have more to do with enhancing human species or overcoming the human species and creating a new form of life?
Generally, yes. It focuses on the former, which is the enhancement of the species. The question that we usually ask in debates is in what ways? Some thinkers have been concerned that altering or enhancing the human species could either cheat us existentially, rob us of authenticity, or alter our humanity. The response has generally been that humanity is a vague term. We already adapt from an evolutionary perspective anyway. So the task is really to spell out what human values we actually want to enhance and attribute, whether that's sympathy, kindness, altruism. What are those values and how do we bring them forward? However, when it comes to actually creating a new form of life, that has been raised as a concern with post-persons. and whether or not there might be a divide in moral status or a conflict of legitimate interests that could emerge that would threaten human rights. And then we might end up with a two-tiered society, and then how do we navigate that? And so, you know, the question that arises is, well, what if it turns out that it's better to have silicon-based children rather than carbon-based children, and so maybe we should do that. So the concern really is whether or not we have a human rights issue if we looked at the post-human, but the majority is generally focused on enhancing the species. So thank you.
So I have a question for Mark about his talk and the notion of distributed morality. This seems very much in tension with our everyday practices of holding people responsible, right? The ways in which we attribute praise and blame. Is this new way of thinking about morality going to require a revolutionary change in those practices?
I would say that I think we need a revolutionary change in those practices anyway. But yeah, I do. I think that it does. I think that oftentimes there's this kind of, for lack of a better term, scapegoating in terms of responsibility, right? That responsibility or moral responsibilities or causal responsibility is a pretty complex notion that we use some sort of shorthand habits to deal with. But I think that if we look at issues of machine learning, we find that those really don't work in a lot of instances. They're more problematic than they are solutions to the problem.
Okay, thanks. Our next question comes from Paul Franco, and it's for Justin. He asks, do feedback loops or looping effects complicate how we assess the accuracy of algorithms predicting recidivism? For example, if someone is labeled high risk, that presumably affects their behavior in some way and also makes them more likely to be surveilled by the relevant authorities, etc. And so maybe being labeled high risk makes you more likely to be arrested. Would that complicate our assessment of accurate or erroneous predictions?
So I think that there is a real worry about these feedback loops, but it's, I think, less with regard to surveillance and arrest and in terms of longer incarceration sentences and the effects that has, right? So I didn't get to talk about this in the talk, but one of the main ways in which these tools are used is in sort of pre-sentence investigation reports where if someone has been convicted of a crime and the judge is deciding what sentence to give, they will see the results of this algorithm and see whether an individual has been labeled high risk or medium risk or low risk, and will use that in part to assign a sentence to that individual. And clearly how long of a sentence one gets will have kinds of feedback loops that one is talking about. And I mean, given the fact that we know that at least some of these algorithms systematically overestimate the risk of Black and brown people and underestimate the risk of white populations, it's sort of curious to me why one would think that the use of these algorithms could be effective in reducing racial discrimination in sentencing and incarceration and the like. So yeah, I think those are serious worries.
Okay, thanks, Justin. The next question is a question for Elyse, and it's also from Janet. Isn't the value of a capacity something that needs to be assessed not in the abstract, but in the light of what kind of world the person with or without the capacity is in, right? So it's a sort of shift of focus from personal enhancement to enhancement of the society and constructed world.
Oh, thank you, Janet. Absolutely, yes. This is actually sort of where a bit of the debate on moral motivation and moral enhancement has moved such as enhancing the trait of altruism so that we help create a society. It's sort of, the goal is if we can change humans, we can alter them, then we can work on them from the inside out to make a better world. But also in this debate, we have the general question, which is, but shouldn't we be working on our society? This is a point raised from disability scholars and philosophers, that maybe creating a more inclusive society is a better use of our resources. You know, we can think about this in terms of universal design in education, or also giving access to healthcare for everyone, rather than focusing on changing each human trait by trait and hoping that we work together and make a better society over time. So you hit the nail on the head. That's exactly where there's disagreement and criticism. So thank you.
Okay, good. We've only got 2 questions left in the queue and plenty of time, so please feel free to use that function on the right-hand side of your screen and enter a question. The next question is for Dan, and it's about how the broader view of open science plays out in cases where information security is at a premium. Science in a military context, law enforcement, and so on.
Yeah, I'm not sure about the military context. I know in the context of policing, there's a lot of push. Sort of open government advocates are really interested in local governments, including police, publishing more data about their practices, although I think often this is focused on data about, for example, individuals who are arrested rather than policing practices per se, to go back to some of the conversation surrounding Justin's talk. I'm more aware of ongoing conversations in areas like conservation biology, where there are concerns about publishing data related to the locations of endangered species, especially when those species are targeted by poachers. And then conversations, for example, in the census surrounding the various data products that the census releases, especially individual level data, and how to ensure security and privacy in those cases. There are a lot of technical discussions that I've sort of gotten peeks at in the census context. I believe the term is differential privacy, where the idea is that you can release individual level data, but you analyze the information content in a technical sense of the data that's released in order to minimize security and privacy risks. These conversations again resemble some of the things that Justin was talking about. So there are explicit discussions of certain kinds of epistemic risks in this context, but not others. So for example, there are a lot of focus on security and privacy in these contexts, with much less focus on whether, for example, certain individuals or certain groups might be more highly surveilled, for example. Less attention, for example, to how the data will be used in these contexts. So yeah, there are a lot of discussions in a lot of different places about open science and how this plays out. And I think the discussion has been, for the most part, kind of technically dominated, with only partial considerations of the kinds of issues that Justin was talking about. I don't know, Justin might also have something to say here.
Justin, you have any thoughts?
Sorry, my mic a lot of that was garbled for me. I'm not sure if I'm having connectivity problems or not. So,
Dan just ended with saying that he thought maybe you'd have something to say about the question about open science and information security as well.
I think I missed too much of it to be able to comment. Sorry.
No worries. No worries. Okay. Let's see. Next question is for Mark, and it's for Jan Muntien. Jan says, I am interested in the coupling that Mark talks about, but I may have misunderstood the exact concept of coupling. Does it involve a process of learning, of behavioral reading from humans to GAN and vice versa, something like a mimicking skill, or is it something more substantive like a causal connection between the two types of moral agents? I think I have a similar worry about moral responsibility and about moral justification that may be very different for GAN and for humans. So Mark, do you have any thoughts about that?
Yeah, I mean, I would say that it's a causal connection often. More than anything, it's a connection with regard to activity. It's not as if the activity of humans and the activities of GANs are completely and utterly separated from one another. And therefore, oftentimes the outputs are due to the activities of both. But really, we're looking at the processes more than anything. And within that, we're looking at causal processes and really a feedback loop of processes. That's why I include that arrow that's going in a circle on that graphic of the icons between the neural network and human beings.
Okay, thanks, Mark. Next question is from Fred Grinnell for Elyse. I think related to Janet's question from earlier about the distinction, if there is one, between the issues of justice raised by genetic enhancement, cognitive and physical enhancement, versus what's called moral enhancement. So could you talk a little bit more about the idea of moral enhancement and whether it raises the same issues we've been discussing?
Yes, and thank you, Fred. The issues of that really sort of arise are, are we going to focus on capacities that we generally find enriching in our lives, which could be, better health or a better memory or more intelligence, or is it the more of the focus, a better focus for us to be on enhancing moral traits? And that's been sort of the shift to take a look at moral enhancement, to say, is it possible to engineer humans really from the inside out? Because if we see this in climate change, it's the problem of moral motivation. How do we get people to actually take action and do the right thing? How do we get people to care about others? And so the thought has been similarly to say, if there's a way to, increase, our morality as humans, then maybe we'll create a better society. This runs into issues of moral pluralism and also issues of justice, where we can run into conflicts about legitimate interest, which values we should choose, how should we prioritize it. But it also runs into the general conflict of sort of what we referred to back with Janet's question, and this goes to Dan's point about, pragmatic virtues. The fact that maybe a better way is to look at redesigning our society so we nurture the development of these virtues from the outside in, and where those resources should be spent. Thank you.
Okay, thanks. We have a related question for Mark, which is, does distributed morality assume the existence of a core set of moral values that are given a priori, or is it the case that the agents would reach individualized values with certain common elements?
It doesn't presume an a priori set of moral values, but I don't think we have to go to this. I'm not sure of exactly what an individualized set of values would be. I think it does refer to values that are inextricably linked with experience. So we can't separate, I don't agree with the value fact distinction at all. And I think that distributed morality can coincide with that. The idea that values are something that we bring to the world regardless of wanting to or not. And so those values are constructed through our experience, but I don't think they have to be a priori. They're definitely not absolute.
Okay, great. Thanks, Mark. So we have no new questions in the queue. So unless one pops up now, I'm going to go back to our presenters and ask if each of them has a kind of follow-up final thought based on the discussion here today. So why don't we go in order and start with Elyse.
Well, thank you. Thank you, Matt, Magda, and Amanda for this incredible panel. I've really enjoyed it. I've enjoyed all the talks. One of the common themes that I really saw that we are all watchful for is the bias that can enter through science and technology, especially these emerging technologies, and how should we actually be wary of the possible prejudices that can be built in operating in the background. And so I just want to thank you all for the great points, and I want to thank the audience for the really fun questions. The topic of genetic engineering and genetic enhancements is still on the verge of what kind of designer babies we might have for the future, but it's something that we have to be watchful of for multiple conceptions of the good. So thank you.
Okay. Justin's having some network issues at the moment, so I'm going to go next to Dan. Dan, do you have any final thoughts?
Yeah. So I think my final thought is how much I love the VMST community and how valuable it is as a forum for working on values in science and socially engaged, socially relevant philosophy of science and bioethics as well, of course. I think as philosophers of science and historians of science in the audience probably know, the Philosophy of Science Association and the History of Science Society are no longer meeting together, and so as a consequence, they recently announced that the Joint Caucus for Socially Engaged History and Philosophy of Science has been dissolved. Yeah, it was buried at the bottom of one of the PSA announcement emails recently. Yeah, and I think that's really sad. We don't have a lot of venues where we can focus on doing philosophy of science that speaks really directly to social issues. And I think VMST has been one of those venues. And so I'm really glad that like the community that you have built here, Matt, with the support of Magda and the other center folks, has like really nurtured work in this area.
Thank you, Dan. Let's go now to Mark. Final wrap-up thoughts from Mark.
Well, I want to thank everybody at the center for, facilitating this. I was disappointed, obviously, when we couldn't meet in person because I always enjoy this conference, but this was a really great opportunity. My piece is really I'm mired in it as a work in progress. So if anybody wants to take a look at drafts, I would love that for commentary. I would really appreciate that. But thanks a lot. I always love seeing all of you, and I hope that we can continue doing this either, face-to-face or through Scopic media. Thanks a lot.
Okay, thanks, Mark. Justin thinks he can try to get a word in, so let's go now to Justin.
Sorry, can you hear me now? Sorry, I'm having some issues here.
Yes.
Okay, great. So I wasn't able to hear what the others were saying, so I'll just keep this short. And just to again thank the organizers for organizing this, and also to express sort of my sadness that we aren't able to meet in person, because this is one of the conferences that I always really enjoy going to and find really valuable. One thing about all of the talks that I just wanted to note was that all of them do what I think philosophers should be doing, which is engaging in a sort of rigorous and systematic manner with issues that are really pressing, and engaging kind of societally wide controversies and issues that are really kind of in need of systematic work. And so I'm happy to see all of the other presenters and doing work like this. And this is characteristic of the work that happens at your conference every year. So thanks again for organizing this.
Okay, thanks, Justin. And thanks to all the presenters for your kind remarks and your wonderful talks. I was pleased by every one of them, and the great discussion we had afterwards. I had a lot of trepidation about doing an online event, and it went extremely well. So thank you all. Thanks for those in attendance who stuck out the entire event, and look forward to future events that will be announced on our website, as well as a recording of this symposium. So thank you all, and have a good weekend.